The last thing we need to learn in Chapter 5 is the triangle inequality theorem. And the triangle inequality theorem says something very simple. It says the sum of the lengths of any two sides of a triangle has to be greater than the length of the third side. And here's what that means. If you take any three sides like 2, 4, and 10, if you lay down that long stretch of 10, and then at either end you're going to connect the pieces of 2 and 4. Well, 2 is only going to go so far, and 4 is only going to go a little bit farther than that. The problem is 2 and 4 only adds up to a total length of 6. So even if you laid that 2 directly on top of the 10, and you laid that 4 directly on top of the 10, you're still going to have this gap in between that isn't going to make a triangle. So there's a special relationship that exists. The two smaller sides have to add up to be bigger than that third side, otherwise it won't even connect to make a shape. So we're going to try to determine if the following lengths could even be used to make a triangle. So number 1, 6, 5, and 4. We look at the two smaller lengths. 4 plus 5 is 9. 9 is bigger than that third side of 6, so yes, I could make a triangle out of this. In number 2, if two of the sides are the same, we just pick one of them to be the longest. So 1 is smaller, and we'll say 100 is the other one. 1 plus 100 is 101, which is bigger than that third side, so yes, these lengths will make a triangle. In number 3, 13 and 15 are the smallest sides. 13 plus 15 is equal to 28. 28 is not bigger than 28, so this isn't going to make a triangle. And if that doesn't make sense, think of it this way. You take your longest length of 28 and you lay it down. You're then going to put a length of 15 at one end and a length of 13 at the other. Well, that 13 and 15 aren't going to connect up here because they'll be too short. And by the time you get them to connect, your 15 will be hitting your 13 directly on top of the 28. So it's going to make a straight line, not a triangle. So if the two sides are equal, you still don't get a triangle. So number 3 is no. In number 4, 9 plus 9 is 18. 18 is bigger than 9. Yes, I'll get a triangle out of that. In number 5, 2.6 and 4.4 are my smallest. 2.6 plus 4.4 is 7. 7 is bigger than that third side of 6. So yes, I'll get a triangle here as well. And number 6, here's another no. 200 plus 50 is 250. 250 equals the third length of 250. It's not bigger than, so I'm not going to get a triangle using those three lengths. Extending from that idea says if one side of a triangle is longer than the other, then the angle opposite that side has to be a greater measure than the angle opposite the shorter one. And this makes sense. The more you open up your angle, the longer leg you're going to have to connect those two. So if I make a very small angle, I'm not going to need as long of a length to connect them. That's all this is saying. And this is saying it's within one triangle. It also works the opposite way. If one angle is greater, then the side opposite that angle is going to be bigger than the side opposite the smaller angle. Say the same thing in two different ways. So what conclusion can you draw from the given information? In example number 1, if I'm told that xy and xz were the same, well, that's an isosceles triangle. So that would tell me that I could draw across to angle y, draw across to angle z, and say that angle y is congruent to angle z. This we've been doing before. Now we're going to step back and say, well, what if they're not equal? What could you still conclude? So for number 2, if the measure of angle y is bigger or greater than the measure of angle z, what can I tell you? Well, the side opposite of angle y is xz, and the side opposite of angle z is xy. So if y is the bigger angle, then its side xz should be bigger than the side opposite z, which is xy. And that's all those theorems really say. So let's look at another one that gives me sides. In number 3, it says that xy is smaller or shorter in length than xz. So again, it's always about the opposite angle of the opposite side. The angle opposite of xy is angle z. And the angle opposite of xz is angle y. So there's a relationship here. They're not equal because the sides aren't equal. But if xy is the smaller side, then that means angle z is the smaller angle. So angle z is less than angle y. And those are my conclusions. Not big mind-blowing ideas here. You're not going to get a specific number, but we do still have a relationship. So let's look at another example. We get some different shapes inside of a quadrilateral here. So number 4 says, which is greater, the measure of angle 1 or the measure of angle 2? Well, angle 1 is across from a side of 10. Angle 2 is across from a side of 8. 10 is bigger than 8, which means angle 1 has to be bigger than angle 2. Likewise in number 5, which is greater, angle 3 or angle 4? You always look across. Angle 3 is across from a side length of 16. Angle 4 is across from a side length of 15. So these look very close to isosceles, but they're not. 16 is bigger than 15, so the bigger the side, the bigger the angle. So in this case, angle 3 is greater than angle 4. Very simple theorem to use. Next picture. Which side of triangle RTU is the longest? So if I'm looking at RTU, I don't have any measurements in here to figure out which is the longest. So the first thing I need to look for is some measurements. Well, if this angle is 110, it's a linear pair with angle RUT, and linear pairs have to add up to 180. So this angle is 70, because 70 plus 110 is 180. I only get 3 angles inside of a triangle, so 70 plus 30 is 100, leaving me 80 degrees for this angle. So now that I have some angles, I can compare the sides. 80 is the largest angle, so across from the 80 would be my longest side, which is side TU. Now it says which side of triangle UST is the longest. Well, UST is this triangle on the right. Now I have no way of knowing what this angle STU is or what this angle RST is. But it doesn't really matter in this case because angle U is 110. So 180 degrees minus 110 only leaves me 70 degrees. And of that 70 degrees, I have to split it between 2 angles. No way is either one of these angles going to be bigger than 110. The obtuse angle has to be the biggest, which means the side across from it, TS, has to be the longest side in that triangle. Now number 8 gives me a little bit more information. It says if TU is an angle bisector, which side of triangle RST is the longest? So let's back up a second. Having an angle bisector isn't going to change my 70 degrees from the linear pair or my 180 in this triangle. But if it's an angle bisector, it's cutting angle T into 2 congruent pieces. Well, that means I do know that this angle of 30 will match this angle of 30. So 30 degrees plus 110 degrees is 140, leaving me 40 degrees for angle S. So now I need to compare the angles R, T, which is actually a full 60 degrees, and S. So in triangle RST, 80 degrees is still the biggest angle, so I draw all the way across to side TS, and side TS is still the longest side in that triangle. Last 3 examples. Name the angle with the least measure in triangle LMN. So a triangle LMN has sides of 10, 7, and 6. So if I'm looking for the least measure, I'm looking for the smallest side. The smallest side would be side 6, and I draw a cross, which would be angle N, is going to be my smallest angle. Okay, number 10, which angle in triangle MOT has the greatest measure? So triangle MOT. If I'm looking for the greatest angle measure, I'm looking for the biggest side of 5, 8, and 9. 9's the biggest, so I draw a cross to its angle. Angle T has to be the biggest angle in that triangle. Now number 11 is a little bit trickier. It says name the greatest of all 6 angles in the 2 triangles. So let's back up. If I just look at the top triangle, I know that 10 is the biggest, so angle LMN is the biggest in these 2 triangles. However, it's just the biggest in this triangle on closer inspection. This angle is vertical to this angle, which means these 2 angles are the same. But we already stated in number 10 that angle T was bigger than that angle M. So even though this has a side of 10, if this angle is bigger than this angle right here, if this angle is bigger than the other 2, but it's equal to this angle, but angle T is bigger than angle M, then angle T is still the biggest out of all 6 angles. So angle T is the largest.